Bronsted-Lowry concept of acid and base. In our previous lecture, we have learned the Arrhenius concept along with its limitations. But now the Lowry-Bronsted tries to overcome the limitations of the Arrhenius concept. So let's have an introduction about the Lowry-Bronsted concept, that what was it. So the scientist in the year 1923, he was a chemist, Danish chemist, and name was J. N. Bronsted, J. N. Bronsted, along with an English chemist, and his name was T. M. Lowry. So they independently expanded the Arrhenius acid-base definitions. So they just try to overcome the concept of proposed by Arrhenius, and that concept was about acid and bases. So let's see what was the Lowry-Bronsted acids and bases as well. So we have Bronsted-Lowry acid. If we have a substance, so acid is a substance that is going to donate the proton, and proton is H positive ion. That substance is known as acid. A substance that is going to donate the proton in a reaction substance is known as Bronsted-Lowry acid. So if we have an example of the Bronsted-Lowry concept, I'm going to rewrite the definition for your convenience, that acids donate the protons in a reaction. They can donate the proton. Protons are the H positive or the hydrogen ions. So this was the concept of Bronsted-Lowry acid. So let's have the example of the Bronsted-Lowry concept. We have HCl plus NH3. So there is a reaction between HCl, it is the hydrochloric acid, and NH3, it is the ammonia. So after the reaction, we have see that two types of ions are going to be produced, NH4 positive and Cl negative. We have seen that the HCl, it has donated its proton. It has donated the proton to ammonia. So according to Bronsted-Lowry concept, HCl can be categorized as acid. So we have many other examples like H2O plus, we have NH3. Here, after the reaction, just gain hydroxide ion and NH4 positive. So here, the water has been changes from H2O to OH negative. So H2O is going to be act like an acid over there. So according to Bronsted-Lowry concept, we can categorize HCl and H2O as acids. So this is the example related to the Bronsted-Lowry concept. Next we have the Bronsted-Lowry bases. Now what are the Bronsted-Lowry bases? So the substances or base is a substance that can accept the proton, that is known as base. So it is the inverse of the acids. If we have a look on the acids, they can donate the protons and the bases can accept that proton. So this was the main concept proposed by the Brønsted Lowry. The two scientists worked independently. Now let's have the example for the Brønsted Lowry base. So first example is, if you have the reaction previous HCl plus NH3, after the reaction we have seen that the two products are going to be formed like NH4 positive and plus Cl negative. After the reaction we have seen that the chloride ions formed and HCl donated its proton, so it will act as a acid according to the Brønsted-Lowry concept. On the other hand, NH3 ammonia, it accept the proton, so it is known as base, because we have learned that the substances that are going to donate the proton are known as acids, and the substances that are going to accept the proton are known as bases. And if I have another example like H2O plus HCl, and after the reaction we just gain Cl negative and plus H3O positive. Here we have seen that HCl has donated the hydrogen ion, so it acts as an acid. On the other hand, H2O, as it accepts the proton, so it acts as a base. So this is the main difference. But in my previous lecture we have learned that H2 is going to act like an acid as well as in base. So water is amphoteric in nature. Amphoteric in nature. So why water is known as amphoteric in nature? We have seen that H2O can accept the proton as well, and it can also donate the proton as well. So it is amphoteric in nature. It is going to act like acid as well as base, and it depends upon that what substance is going to be react with the base. If water is going to react with the base, then it will act like an acid, and if the water is going to be react with the acid, then it will act like a base. So H2O is going to be act as amphoteric in nature. It is having both the properties of acids as well as base, but this is according to the Brønsted-Lowry concept, and what it was not explained by the Arrhenius, it was just explained by the Brønsted-Lowry acid and bases. So this was the simple concept about the acid and bases. Acids can donate the proton and bases can accept the protons. I hope you guys understand about the Brønsted-Lowry concept of acid and bases. And if you have any queries, you can ask me about that in the comment section. For that time, have a good day and Allah Hafiz.